Hi girls, today we are doing a section on algebra. Basically, we're doing simultaneous equations. Okay, so what exactly is simultaneous equations? Okay, when an equation has two unknowns, over here let's take a look. This is an equation x plus y equals to 6. When an equation has two unknowns, basically you do not have a unique solution for x and y that satisfy this particular equation. You think about it. When x is 1, if x is 1, the value of y that can satisfy this equation will be 5. Am I correct? If x is 2, y can be 4 because 2 plus 4 is also 6. If x is 3, y can be 3. So 3 plus 3 is also 6. In other words, the list goes on forever and ever. So we do not have a unique set of values for x and for y when there are two unknowns in one particular equation. Hence, two unknowns in a particular equation, you will require two equations. Okay, two equations in order to find a unique set of values for your x and y. However, it doesn't necessarily mean that when you have two unknowns, two equations, you will always get a unique set of values for x and y. It doesn't mean that. Why is that so? Think about it. Okay, so over here right now, I added in a second equation. Okay, so we have our first equation. So we have x plus y equals to 6. That's our first equation. We also have a second equation which I just added in. 2x minus y equals to 9. That's the second equation. Okay, now if we ask ourselves, is it possible to find a set of values for x and y that satisfy both of the equations concurrently at the same time? That's why we call it simultaneous equation, right? Can you solve them together at the same time? So to solve a pair of simultaneous equation, there are many different techniques. There are, example, you have the elimination technique, you have substitution technique, the graphical technique, and of course, the matrix technique. Okay, so for today, we are concentrating on the elimination technique. Okay, there are many techniques, but we are just concentrating on what? Elimination technique. So what exactly is the elimination technique? To solve a pair of simultaneous equations using the elimination technique, basically what we are intending to do is we intend to eliminate one of the unknowns, either x or y. Okay, we intend to eliminate them. That's why we call it the elimination technique. Okay, so in this case right now, let's say I intend to eliminate variable x, okay, the unknown x. So what can I do? So if I take a look at this situation, I realize that the coefficient of x in this case is 1. Am I right? Because although there's no number here, there's an invisible 1 over here, right? So the coefficient of x is 1. The coefficient of x in the equation 2 is 2. So to eliminate one of the variables, what I can do is, my intention is to make both the coefficients of that unknown the same. So what I can do is I can take this and multiply equation 1 by 2. Okay, watch what happens when I multiply equation 1 by 2. So this will become 1x times 2 becomes 2x. This becomes y times 2 becomes 2y. 6 times 2 becomes 12. So I have just formed a new equation, equation 3, from the equation 1 by multiplying it by 2. So always, you must not forget, okay, to always multiply the left and the right hand side of your equation by the same constant, okay, by the same number. So remember, if I multiply by 2, I have to multiply every term in the equation by 2. The x, the y, and the number. Don't forget the right hand side. You have to multiply the number, the constants on the right by 2 also. Okay, so if we take a look at equation 2 and equation 3 right now, if I have to rewrite it, okay, I rewrite equation 2 below. You realize this is 2x plus 2y equals to 12. 2x minus y equals to 9. So how can I eliminate them now? Okay, I'm going to share this technique with you. This will help you to remember it better. When the operational signs of the coefficients are the same, you subtract them. When it's the same, you subtract. When the operational signs of the coefficients are different, you add them. Okay? So in this case, we observe that the 2x here is positive, right? The operational sign of 2x is also positive. When it's the same, you subtract them. See, you subtract them. So what we do is we take equation 3, subtract equation 2. So what do we have over here? So basically what we have is this situation, 2x plus 2y. Okay, the left hand side will subtract the left hand side. So 2x minus y equals to, the right hand side will subtract the right hand side, 12 minus 9. So if you were to just expand and simplify this, we have 2x plus 2y minus 10 plus is minus 2x, minus 10 minus is positive y plus y, and the 12 minus 9 is 3. So you look carefully, the 2x minus the 2x basically will eliminate itself. And what do we have left? So we are left with 3y equals 3. And that leads us to y is equals to 1. Okay, so now that we have solved for the value of y, how do we find the value of x? This is the easy part. So all we have to do is just substitute the value of y that we have just found, y equals to 1. We substitute into any of this equation, either equation 1 or equation 2. In this case, I choose equation 1 because it looks simpler. I like simple things. So in this case, when y equals to 1, if I were to sub y equals to 1 inside equation 1, look at what happens, okay? X plus y, in this case I replace y with 1, equals to 6. So x plus 1 equals to 6, x equals to 5. So what have I just done? I have solved for a unique set of values that when x equals to 5 and y equals to 1, it satisfies these two equations simultaneously, concurrently. So what happens when we have already found the value of x and y that satisfy this set of equations? So do we just pop the champagne and celebrate? Yay! Do we do that? No, not yet. Okay, what do we have to do? We always check. Well, we are maths people, so we always check. So all we have to do is take the value of x and y. Okay, the value of x is 5, the value of y is 1. We sub it into both equations to check whether are we correct or not. Okay, does the value of x equals to 5, y equals to 1, does it really satisfy both equations? Let's check. 5 plus 1 is 6. Very good. Let's check the next one. 2 times 5 is 10. 10 minus 1, y is 1, is 9. So there you go. We have just checked and we are correct. So are we able to find a set of values for x and y to solve these two equations simultaneously? Okay, let's run through the whole process right now. Okay, so I let the first equation be equation 1, and 2x plus y equals 1, let it be equation 2. Okay, let's say my intention now is to get rid of variable x. Okay, how do I get rid of variable x? Over here I realize that this is 3x for equation 1 and equation 2 is 2x. So in order to eliminate the variable x, my intention is to make both the coefficients of the variable x the same. Okay, so in this case, when I see a 3, I see a 2 here, the first number that comes to my mind, the LCM of 3 and 2 is the number 6, right? So what do I have to do? So in order to have a coefficient 6, okay, for the x term, I multiply equation 1 by 2. To get a coefficient of 6 for the variable x, for the equation 2, I'll multiply equation 2 by 3. So by doing this, look at what I have. Okay, from equation 1 times 2, I'll have 6x plus 2y equals to 0. From equation 2, multiplied by 3, I'll have 6x plus 3y equals to 3. So in this case right now, I have equation 3 and I have equation 4. Okay, remember what I said earlier regarding the operational signs of the coefficients of the variable that you are intending to eliminate. when the operational signs are the same, you subtract. If they are different, you add up the two equations. Okay, when operational signs are the same, we subtract the equations. Okay, so in this case right now, let's subtract them. Okay, so if I were to take equation 4 minus equation 3, if I were to subtract them, what will I have? I'll have 6x plus 3y minus 6x plus 2y equals to 3 minus 0. Left hand side, subtract the left hand side. Right hand side, subtract the right hand side. So what will we end up with? We will have 6x plus 3y minus 6x minus 2y equals to 3. So 6x minus 6x is 0. 3y minus 2y is equals to y. So y equals to 3. Okay, so now that we have found the value of y, how do we find the value of x? So we can simply just substitute the value of y equals to 3 into any of the equations. Okay, equation 1, 2, 3 or 4. But I would prefer equation 1 because it looks the simplest of all. Just substitute y equals to 3 into equation 1. We will be able to find the value of x very quickly. So when y equals to 3, we plug it into equation 1, we will have 3x plus 3 equals to 0, 3x equals to minus 3. By bringing this positive 3 to the right hand side of the equation, it will become minus 3. So if 3x equals to minus 3, x must be equals to minus 1. So is there a better way of working through this simultaneous equations problem? Other than removing variable x, is there another approach that we can take such that the whole process can be much simpler? We can always consider eliminating variable y. Okay, let's take a look at this. So let us say I'll try to eliminate variable y right now. Okay, let's take a look at this. Will the whole process be easier? The coefficient of y, in this case, is positive 1. The coefficient of y for equation 2 is also positive 1. You realize that in this case, I don't need to multiply either of the equations, okay, by anything. The coefficients of y is already the same. So if that were to be the case, so do you think by eliminating variable y, you'll make the whole process of solving the simultaneous equations easier? Okay, let's try. When the operational signs of the coefficients of the variables that you are intending to eliminate, they are the same, what do? We subtract, right? So I can simply just take equation 1, subtract equation 2. So I have 3x plus y minus 2x plus y. So the entire left hand side of the equation minus the entire left hand side of the equation, the right hand side, subtract the right hand side. So if by expanding and simplifying it, the y minus the y will be 0. I will have x equals to negative 1. So after finding the value of x equals to minus 1, I just plug it into equation 1, and then I will have 3 times minus 1 plus y equals to 0. So minus 3 plus y equals to 0, y is equals to 3. So is there another easier technique of solving simultaneous equation? What I'm about to show you now is a dummy method. Okay, a dummy method on how to solve simultaneous equation. This involves no understanding. Okay, but at the end of the day, I would love to hear from you. Why does this work? Does this work all the time? Is it magic? Okay, how did it come about? Okay, let's try. The process basically looks like this. Okay, the first thing you have to do is to make sure you arrange everything in x, y, number. X, the y equals to number. Equation 2, x, y equals to number. Okay, after doing that, what you do is the positioning. It's all about the positioning. So you can jump straight into finding the value of x. So x equals to, you simply take this, the coefficient of y, multiply by the constant of the second equation. So in this case, it's b times f, minus is always minus c times e over here. Okay? Then you divide everything by a denominator. What is the denominator? In this case, the process looks like this. B times d, this times this, minus A times C. This times C. This requires no understanding, just a recognition of positions. Okay, let's try this now and see if it works for our problem. Okay, the value of x equals to, okay, watch out, remember the first thing you do is arrange in x, y equals to number. X, y equals to number. Okay, so we have our equation 1, equation 2, right? X, y number, x, y number. So x equals to, what is the coefficient? What do we have here? This is an invisible 1, right? So this also an invisible 1. Okay, so all you have to do is just take this 1 times 1 gives you 1. Okay? Minus is always minus 0 times 1. Divide by, what is the denominator? Okay, look at 1 times 2 minus 3 times 1. So what do we have? We will have 1 minus 0 over 2 minus 3. This will result in 1 over negative 1. 1 divided by negative 1 is equals to minus 1. Ta-da! So after finding the value of x equals to minus 1, you simply just sub it back into equation 1. So when this part is the same, when x equals to minus 1, what do we have? Y will be equal to 3. So this process is a dummy method. Okay, but I hope you appreciate the beauty of this whole process. And wow, why does this work? You tell me, why does it work? Okay. Thank you for spending time watching the video. And I truly hope that whatever I've shared with you helps you deepen your understanding by a little bit. Okay, thank you very much. Thank you and God bless.
We did it! We did it! We did it! Yay! Always team up. We did it!